Hello, and welcome to the FireVoxel tutorials. This tutorial presents the most attractive method to co-register two three-dimensional images. This method is fast and requires no parameters to be adjusted, and therefore it is often the method of choice for co-registering images acquired during the same exam. FireVoxel's convenient basic command for co-registering images uses the orientation and position information extracted from the DICOM headers. This option works for images acquired within the same imaging session. The images may have different matrix, field of view, and orientation. For images acquired on different days, or if the patient's position changed between acquisitions, FireVoxel contains more advanced commands for 3D and 4D co-registration based on image features. We will demonstrate this basic co-registration using two sets of MR images of the brain. Let's first load a T1 weighted MP RAGE image. Next, we will load a T2 weighted FLAIR image acquired in the same subject about 13 minutes later. The T1 weighted image is in the sagittal plane and has 1 mm isotropic voxels with 176 slices. The T2 weighted image is axial and has a sub-millimeter in-plane resolution, but only 30 5 mm thick slices. We will superimpose the T1 weighted sagittal image, which we will call the source, over the T2 weighted axial image, which we will call the target. Activate the target document window by clicking on the T2 weighted image. On the main menu, select Register using orientation and position tags. We will be prompted to choose between adding the registered volume as a new layer to the target document window or creating a new document. Select Yes to add a new layer. In the Layer Control panel, we will see that a new layer has been nearly instantly added on top of the T2 weighted image. The new layer is named the same way as the T1 weighted image, with an added suffix indicating that it is a co-registered image. We can increase the transparency of the top layer to check the accuracy of co-registration. As we can see, the T1 and T2 weighted images are well aligned. If the patient moved between these two acquisitions, we would need to resort to more complex co-registration methods available through FireVoxel's Register menu. If the source image contains multiple layers, all of them will be transformed by the co-registration command. Let's delete the co-registered layer and repeat the co-registration with the image and an ROI layer. To define an ROI, we will quickly segment the brain on the T1 weighted image using EdgeWave. Draw a seed vector ROI and run EdgeWave. A new layer with the segmentation mask is created, and the orientation and position attributes of the T1 weighted base image are copied into the DICOM header of this new layer. However, for co-registration, it is best to activate the base image. Now let's repeat co-registration with the T2 weighted image as the target. Both the source image and the segmentation mask have been co-registered to the T2 weighted image. The segmentation mask has been added as the top layer over the T2 target image and the co-registered T1 weighted image. This co-registration command uses DICOM orientation and position attributes and matrix algebra to transform the source image and align it with the target. Let's open the header information of the T1 weighted source image. The relevant attributes are stored in the Image Orientation Patient and Image Position Patient fields. The image position specifies the X, Y, and Z coordinates of the upper left-hand corner of the image. The image orientation contains the directional cosines of the first row and first column of the image with respect to the patient. For sagittal T1 weighted image, the first row is aligned with the positive Y direction and the first column with the negative Z direction. If we now look at the orientation of axial T2 weighted target image, its first row is along the positive X direction and the first column is along the positive Y direction. The co-registered T1 weighted image has the same orientation and resolution as the T2 weighted image. Coregistration based on DICOM tags also works for CT volumes acquired within the same exam. In addition to DICOM, this command may work for the NIfTI format that can unambiguously store the image information. For simpler image formats, such as Analyze, this method does not work. This concludes this brief description of FireVoxel's basic coregistration option. If applicable, this command provides fast and accurate image alignment. For more complex scenarios, FireVoxel offers comprehensive tools for 3D and 4D coregistration. For more information, please visit our website. Thank you.